So we've checked f of g of x. We have to check g of f of x here. So g of f of x is going to be 1 minus 5 times 1 over 2x plus 5 over 2 times 1 over 2x plus 5. Like this one looks even worse than the last one. So we could, this is like 5 over 1, this is like 2 over 1, so we've got 1 minus 5 over 2x plus 5 over 2 over 2x plus 5. And the only denominator that we have is 2x plus 5. It's the same on top and bottom. So we can do the same thing we just did. We can multiply by 2x plus 5. And so we will distribute here, which means that 1 times 2x plus 5 will be 2x plus 5. And then when we distribute to 5 over 2x plus 5, what happens? It cancels with that denominator, which is the reason we chose to do this in the first place, right? So we just have a minus 5 there. And then when I multiply this 2x plus 5 by the denominator, what happens? Those cancel as well. We just get a 2. And from here, the 5's will cancel, so we get 2x over 2, which is just going to be x. So we have proven that those are inverses. Okay, so part of your homework will ask you to do this. It will ask you to prove that two functions are inverses. So to do that, you find f of g of x and g of f of x. Okay, so let's look at, let's see, there's nothing else. Oh, wait, okay. One other thing about inverses. If we reflect something over the line y equals x, then its coordinates change places. So, for example, here, I have the point 1, 3. If I flip it over the line y equals x, I think I said x-axis earlier, I meant y equals x. If I flip it over the line y equals x, then its coordinates become 3, 1. Maybe. So these two, the coordinates, the x and y just switch places, and that reflects something over the line y equals x. The graph of f inverse is the graph of f of x reflected over the line y equals x. So if we have an inverse, or a function, we can find its inverse by reflecting it over that line y equals x. So it also means if a graph contains the point AB, then the inverse has the point BA. Okay, so that is something that you will look for. Sometimes I think it's really hard to tell if graphs have been flipped over the line y equals x. X-axis is easy. They flip upside down. Y-axis, they just flip sideways. But over y equals x is a little bit tough. So if you're looking at two graphs, for example, let's graph one here real quick. Let's say we had two graphs. Oops, wrong thing. This one. Let's say we're looking at y equals x to the third and y equals x to the 1/3. Okay. Now, I know that those are inverses. I know that they undo each other because this is the cube root of x. But sometimes it's kind of hard for me to think about whether or not this is really reflected over the line y equals x. This is probably not the hardest because it does pass through the axis. But if I find a point that's on the graph, like I know this is the point 2, 8, I could check and see if the point 8, 2 is on the inverse. And that kind of confirms to me, yes, these have been reflected. If I have a point over here, like negative 8, 2, whenever I reflect it, oh, that should be negative 2, then that means the point negative 2, negative 8 should also be on the other graph. So that can kind of help you check. There's a section on your homework where you're going to have to match graphs to their inverses. So if you're having trouble deciding if it's been reflected over the line y equals x, you can pick a few points to see if they have been flipped there. Okay? All right, that is all I have on that section. So, so let's look at the other page that I gave you. For a little more about inverses. So this is probably a new term right here that you see on that first page. Strictly monotonic. Strictly monotonic means that your function is increasing on the entire domain or it's decreasing on the entire domain. So always increasing or always decreasing. What we're going to be concerned with here is what we call a one-to-one function. Have you guys heard one-to-one function before? So when we learned about functions, we learned that whenever you have, that you can have a function, and it will be a function as long as its x's do not repeat, right? We also did like a vertical line test. So for each x value, we can only have one y value. So like this would be a function because none of the x's repeat. The y here repeats, but that's okay. It's still a function. But a one-to-one function is different. Oh, if you think, you guys, did I tell you about the boys and the girls and the functions? So whenever I teach this in Math 1, if you have 2 X chromosomes, you're a girl, right? Got that right. And then if you have an X and a Y, you're a boy. So in the society, unfortunately, that we live in sometimes, this is okay. All these girls only have one boyfriend. But what about boy number 5 here? He has 2 girlfriends, and that's okay, right? So for a function, unfortunately, sometimes our society views things that way, although it's not right, that, you know, if you think of the words you would use to refer to boy number 5 here, they are somewhat, sometimes even viewed as positive. If you think of the words you would use to describe the same girl that has more than one boyfriend, they're not very nice. There's no positive words that are used there. So functions, each girl, each X, can only have one boyfriend, one Y. But a one-to-one function is how the world should work. Okay? A one-to-one function is really how the world should work, where each X has one Y and each Y has one X. So neither X's nor Y's can be repeated in a one-to-one function. So a one-to-one function is a function where each X has one Y and each Y has one X. So this is monogamous relationships here where you only have one boyfriend and your boyfriend only has one girlfriend. So this is the way the world should work here if you're going to think of it that way. So a one-to-one function, if that's the case, none of the X's can be repeated and none of the Y's can be repeated. So whenever we did functions, we did a vertical line test, right? And if it passed the vertical line test, it was a function. So like this one is a function. It passes the vertical line test. This one is also a function. It passes the vertical line test. But that y's cannot be repeated either. So to test to see if a y is repeated, we can do a horizontal line test. And we can see here for this graph, it passes the horizontal line test. So if a function will pass vertical and horizontal line test, then it is a 1-to-1. So this is a 1-to-1 function. Over here, this function does not pass the horizontal line test. We've got, right here, if this was at 1, girl 1 has 1, 2, 3 different boyfriends. In this case, you got three different y's that go with that, or 3 different x's that go with that single y. So this is not 1-to-1. It's still a function, but it's not 1-to-1 for there. In order for a function to be 1-to-1, it also must be strictly monotonic. It's got to be always increasing or always decreasing. Because if it switches from increasing to decreasing like it does here, you're going to end up with a maximum or minimum, which is going to give you something that's not going to pass that horizontal line test. Okay. Now I say all of this because a function has an inverse if and only if it is 1-to-1. So for example, if I have like the graph of f of x equals x squared is a function. We've used it lots of times, right? But if I were to reflect this over the line y equals x, these 2 points, they'll stay where they're at. The point 4, 2 becomes, 4, 2 becomes 2, 4. And 3, 9 becomes 9, 3. Right? And then here, this point is at negative 1, 1. So that's going to become 1, negative 1. We're going to switch there. This is the point negative 2, 4. So that's going to be 4, negative 2. And then kind of see this fills in. So because this function right here is not 1-to-1, it does not have an inverse or a function as its inverse. Now we could take the inverse of this, but what we'll have to do is use 2 different functions to define it because it's not actually a function. We'll have to have a plus or minus somewhere. If we look at this right here, and we are running out of time, if we want to know which one of these has an inverse, we could graph them. So if I had, tell me what it was, y equals x to the third plus x minus 1. So if we look at that graph, that is always increasing, right? I think, let's zoom out, make sure, yeah. That is always increasing. So this has an inverse. However, if we change it, what's that second one tell me? Minus x plus 1. And we look at this graph, does this one have an inverse? No, because it is not strictly increasing. It's not always increasing. So that first one is the answer here. This one has an inverse. That second one does not. And so we are not going to get all the way through the things that I was wanting to do. That's okay. Just need to shorten your assignment a little bit. So this is going to come from page 42, I think. Yes. Yes, page, so your homework, it's going to be page 42. And we are going to do one through 16. 1 through 16. All. Okay. 1 through 8, you're verifying the inverses, so you're finding f of g of x and g of f of x. Some of them will be real quick, some of them will take a little longer. 8 through 12, you're matching graphs of inverses, so you're looking for that reflection over the line y equals x. And then 13 through 16, you're just telling whether or not it would have an inverse. So if it's 1 to 1, it has an inverse. If it's not, it does not have an inverse. All right, so we'll finish up those notes and get into a little bit of what we're going to do tomorrow's deal.